So using the DF1 protocol to connect to AllenBradley MicroLogix PLC. So here's the agenda that we've come up with. We'll be looking at what PLCs use the DF1 protocol, how to configure the PLC using RS Links and RS Logix 500. Then we'll go through step-by-step configuration of the AllenBradley driver tag within VTScada, different scenarios for connecting, and then we'll quickly look at error messages and how you can troubleshoot a connection. And hopefully at the end, we'll still have some time to demonstrate the MicroLogix data logger. So we'll talk about that later on. Okay.
By the way, Victor, before you get started, when you tap the screen, we get a really good view of the VTScada on your lapel. Just so you know. There we go.
Okay. There's that thing.
Yeah, that's good.
Okay, so let's continue on here. So the first thing is which AllenBradley PLC models actually use the DF1 protocol. So the MicroLogix models, 1000, 1100, 1200, 14, 1500, a few of them have been discontinued. The 1200 apparently is going to be discontinued in a couple of years. The older models, PLC 2, 3, 5, and the Slick 500s, they used the DF1 protocol as well. So you can use the information in this webinar to connect to any of those older ones as well, I believe. The newer family of PLCs from Rockwell, the Micro 800 family, the 810, 820, 830, and so on, those do not use the DF1 protocol. They use a version of the SIP driver. It's not the standard driver that we've got in our package. You have to install the driver pack, which is a separate OEM layer that we can provide you no charge. And then you can use the SIP driver that's in there to connect to the Micro 800. I think that Rockwell is planning on phasing out the MicroLogix after several years and go with the Micro 800 instead. Okay, so for demonstration purposes, I've got MicroLogix 1400 here with me. So let me just give you a quick rundown of that. So I'm going to turn the PowerPoint off, and now you should see my camera. And here's the MicroLogix 1400 that I've got on my desk. You can see that it's got a few different connection options. Over here is a mini DIN or DIN 8 connector. It's 8-pin serial RS2, RS232 or RS45. That's port 0. We've also got port 1, which is this Ethernet cable. That's when connected currently. And then we also have another serial connection, port 2. Okay, so those are the three available ports on the MicroLogix 1400. The 1100 doesn't have the second serial port. It has just the port 0 and the port 1. And if you've got the older versions of the MicroLogix, the 1000 or the 1200, then they don't have an Ethernet port at all. Okay, so let's get back to the PowerPoint here. So hopefully you'll see the PowerPoint presentation again. All right, so let's continue on. So configuring the PLC. All right, so we'll need to connect in. If you remember, I had my Ethernet connection from my computer connected to the PLC. I'm going to open up RS Links. You can see that I've got a driver connected here, and here's the IP address for the MicroLogix PLC. All right, so we're currently, it's finding it. You can see browsing node 192.168.1.5. All right, so I'm just going to minimize that and open up my RS Logix 500 application. You can see that I've already connected. So we're online. The ladder is spinning around here. We're in remote run. And let me show you how the channel is configured. So if I open up the channel configuration, just double click here, get this window, and we can program each of the 3 ports that are on the PLC. So here are our choices for the serial port, the port 0. full duplex, DF1 half duplex, and so on. There's a whole slew of them. The ones that we'll be looking at today are the DF1 full duplex and the radio modem. Okay. On channel 1, that's the Ethernet port. Here's where you can specify the IP address, subnet mask, gateway address. I want to point out that here's where you would also designate the PLC to support the DNP3 protocol over an IP. And in addition to that, Modbus. So if the 1400 is actually quite versatile. You can use these other protocols as well. And in some cases, there are definite advantages to going with DNP3 instead of DF1. We can talk about it in the question and answer period at the end if you'd like. Same with Modbus. Okay. So, but for obviously this one, we're going to talk about DF1. And the last channel is essentially the same thing as the port 0. It has the same capabilities. We've got full duplex, obviously, half duplex, and so on. The baud rate is specified here, same with the parity. And the source ID, this is the station number for the PLC. So if we're using a serial connection, it's possible that it could be on an RS-485 network, which means that you could have multiple devices all on one set of twisted pairs. In that case, each device would have to have its station address, and here's where you would set that. Same with the station channel 0. Okay, I think that one other thing, you have also the choice of changing the error detection. CRC is what is the default, I believe. It's 16-bit cyclic redundancy check. You could go with a BCC, which is smaller. It's an 8-bit check. So CRC is probably a better bet. Okay, I think that's pretty much all I need to say there. Well, you can specify other things, like the ACK timeout, the NAC, and the ENQ retries, that kind of stuff. Really not going to get into that during this webinar. That's something specific to configuring the MicroLogix. Okay.
Right.
All right. So we're going to be initially talking to the device using Ethernet. So here's our IP address and subnet mask. That's what we'll need. Okay, so there we go. While I'm in RSLogix 500, I wanted to actually look at the address format. So when you want to pull for a particular register within the PLC, you can see that I've got the data files list opened up here. Each one of these files has a particular type of data. So for example, the B3, if I open that up, we've got binary data. And if I mouse over these things, you can see the tooltip that pops up, and it gives me an address, B3:0/2. That is actually the address that I would use in the VTScada analog and digital status tags to actually talk to this particular data point. Okay, so we use the native addressing that's built into the RSLogix 500 PLCs, or programming language here. So that was a binary. Here's an integer. I've only got a few of these configured, but you can see it's N7:2. So it's the file number or file name, and then the element number after the colon. And then obviously, when we go back to the binary, we're looking at, with a slash, we're looking at an actual bit number. The other thing that's a little bit interesting here is if I'm looking at a timer, I can also look at the accumulator register here by putting a .acc at the end. So it would be T4:0 .acc, and then I would get whatever the ACC value is in the VTScada analog tag. Okay, here you can actually see what the enable and the done bit are. So if you put in .dn, you would also get whether or not the done bit is active or not.
I'm just going to jump in here real quick and point something out for anyone who came in slightly late. What we're looking at here is the software that's provided by the hardware manufacturer, and we're not actually looking at anything we're not actually looking at VTScada at all quite yet, right?
That's correct. Yes, we haven't gotten to that point yet.
Okay,
yes, so all of this is to configure the PLC, and then we'll have to match that configuration within VTScada so that they can talk correctly. All right, so I think we've got this set up. The program that's actually loaded on this PLC is just a simulation program. It simulates a couple of pump stations with flow rates and pump statuses and well levels, that kind of stuff. And if we have time at the end, I can show you a full application that demonstrates all of the different tags that are in here. But for the purposes of this webinar, I want to show you how you can actually configure VTScada to actually talk to the device from scratch. Okay, so I'm going to minimize the RSLogix 500 application here. Let me go to the next slide here and show you the different ways that we can connect. I've got 4 examples in the graphic. So the first one is just a straight serial connection using port 0 or port 2. Second is using a serial connection through modems. It's functionally similar to radio, except that modems could be full duplex as opposed to radio, which is typically only half duplex. And when I say that, full duplex means that both devices can talk at the same time on the wire. With a half duplex, and only one device can talk at a time, which is typical of a serial radio system. So example 2 there would show, the VTScada computer connected to a master radio through a serial connection, and then on the receiving end, there'd be another, slave radio connected to the RTU that's out in the field. Okay, the third one is just a straight network connection, TCP/IP connection, and that's what we'll be looking at first once I get past the slide. And then the last one is rather interesting. We can use an Ethernet connection to go to a terminal server and then talk serially out that to the device. Now, that would be appropriate for, let's say, a radio system where you've got a serial radio connected to a VTScada computer. The problem with a serial connection, obviously, is that you can only have one computer connected to it at a time. So if you want to have redundancy, failover redundancy, so if you want to have a primary VTScada computer and a backup computer, both connected to the radio, the only way that you can accomplish that, if the radio is a serial radio, is to use an Ethernet gateway. So all of the traffic that comes into the gateway comes in over an IP address, and then the IP header is stripped off of that, and the payload, the serial message that's embedded in that, gets transmitted out to the serial radio, and then out to the rest of the devices out in the network, and then vice versa on the way back. So that's a real nice way of taking an older radio network and still having redundancy on it. The single point of failure, obviously, is still the master radio, but at least you can have multiple computers backing each other up on the SCADA or on the HMI side. Okay, so let's move on to the next slide, which is the address formats. We had a quick look at that while we were looking at the RSLogix 500 software. So this is actually an excerpt from the help file in VTScada. I'll pull that up once we've got a tag or a couple tags built, so you'll see where that's located. But it gives you the list of all the different addressing types that we support for the DF1 protocol. Okay, so now I think we'll get to VTScada. So I do have an application built. Oops, here we go. AB driver demo. This is a brand new application. It has not been configured at all. The only thing I've done is I've created the application from scratch. So now we're going to start it up here, and I'll go through the procedure on connecting or creating an AllenBradley driver tag, and then creating the analog and digital status tags underneath that to grab the data. Okay, so it's just about there. Here we go. Now, we're going to start off with an Ethernet connection. After that, we'll look at how to change that to make it a serial connection, so be the same sort of thing. So here's my page menu. I'm just going to open up the overview page here. So that's what everyone should have seen if you ever opened up a brand new application in VTScada. So here we go. There's the tag browser. I'm just going to create a AllenBradley driver tag right at the root position in the tag tree. So you can see that I've been playing around with this earlier. I can either pull it from the recently used tags, because I was doing this earlier just to test it, but I can go to all tag types and then select the AllenBradley DF1 compatible one here. So I'll give it a name. I'll call it my AV driver. There we go. The description, demo driver, and let's go on to the type. So here's the supported PLC types. I'm going to go with the MicroLogix. That's what I've got. And we're going to go with a TCP/IP port connection. Now, this driver, the AllenBradley DF1 driver, is one of the few drivers in our driver list that actually has a built-in TCP/IP port. So we can use that right from here. So I'll just type in the address of the MicroLogix. So 192.168.1.5. Okay. Now, the number of virtual words you can pretty much ignore. That is if you wanted to create a virtual PLC from inside your application. VTScada can actually behave as if it were a PLC2 PLC. And then the number of virtual words would be the registers that would be available in that virtual PLC. We're going to ignore that for the rest of the presentation here. Okay, so the other choices that we've got are an SD card for communication mode, serial or modem. We can store the last output values and enable auto rewrite. So if we lose a connection, when we reestablish the connection, we can have all of the commands, the writes, the set points that we would send out to the PLC to be rewritten. So that's an option. The other checkbox there is a hold. So if we lose a connection, all of the I/O tags that we've got connected to this driver could actually maintain the same value that they've had, or they could go invalid. So that's another option as well. Depends on how you want your application to behave. Since we're using a TCP/IP connection, we don't really need to do anything with the serial tab or the SD tab. So the SD is for an SD card. If you had like an old DH plus data highway plus highway connection, it's a physical device that you would plug into your computer, and that would be the serial port essentially for the data highway plus network. That's really old stuff. We're really not going to cover that unless if you have any questions about that, we can talk about that at the end of the webinar. On the TCP/IP port tab, we could actually specify the address here. The IP port number defaults to 44818. That's specified by Rockwell, so that's the one that the MicroLogix is going to respond to. It has to be set to that. I do believe port number 2222 will also work. I believe that's the RS Links port that's used, but I just use the 44818. That's the easiest thing. If you've got a slow connection, you might want to increase your inactivity timeout. There is a timeout limit and a connect time. So the connect time is how often or how long we're going to wait to establish a TCP connection. Timeout limit is how long are we going to wait to drop the connection if there's no traffic. And there's also an inactivity timeout on the Ethernet IP, which is essentially the wrapper for the DF1 talking to the MicroLogix. Like I said, you may want to increase that if you have a slow network. We can also set the retries. If communication fails, we can retry it before we actually fail the connection. Okay. And the last tab that's in the configuration is the data log read. We'll cover this at the end of the presentation when we look at using data logs within MicroLogix. Okay, so that's it. Really, the whole thing was done here. Okay, we chose the PLC type, the communication mode, and gave it the PLC address. Okay, so there's my tag. I'm going to create my I/O tags as child tags to the driver tag so that they'll automatically find it. So I'll select a new child, and I'll go with an analog status. And there is a, where's my cheat sheet here? Okay, so in the PLC, there is a flow register. So I'm going to create this analog status as a flow tag. Name of flow, area, I don't really need that. Description, I'll just say flow. And we'll go to the I/O tab. Here's where you specify which I/O device you're going to grab data from. Obviously, since I made this as a child tag to the AllenBradley driver, it's going to automatically find that. Now here's where we're entering the address. So for the flow tag, it's register F20, so it's a floating point, :1. Scan interval, 1 second. History address, and the history scan interval, we use those for the data logs. Again, we'll do that later on in the application or in the webinar. Okay, scaling. So here's where we specify our raw values. So in the PLC programming, in the ladder logic, I set it up so that the raw value that VTScada is going to read is already scaled in engineering units. And this particular setup was done from 0 to 5. And then I'm going to change the units to MGD, so million gallons per day. And so the unscaled is going to be 0 to 5, and we'll change the scale to 0 to 5 as well. And there we go. There's our first tag. I'm not going to bother with the alarms or any of the other stuff. Okay, so there we go. And you can see that we got a value already. So that means that we're talking to the device immediately. If I wanted to add a digital tag, I could do that underneath here. New child, I'll go with a digital status this time. Oh, I don't have my cheat sheet for a digital tag. I'll just use one that I know is valid. So digital status 1 and demo digital tag. Okay. Go to the I/O tab here. Again, the I/O device is automatically found since we're a child tag to the driver. And bit 0 address, I know that there is a bit 3:3/0 register that's available. And here we go. I hit OK, and we should see that pop up. There we go. Okay, so there you go. That's all there is to it. Okay. Digital control, analog control, they're configured exactly the same way. Okay, so you just have to have the correct address. We can, let's see. Well, what I probably ought to do is go on to the other connection types so we can demonstrate that. And then we'll come back and look at troubleshooting if you run into issues with bad addresses or the connection is dropped or something like that. Okay, so let's see. We've been looking at the Ethernet connection. Let's go to a straight serial connection. So what I'm going to do now, let me just go back to the camera here. So you should now be seeing me. Yep. Okay, here's my PLC, and you can see that I've got this Ethernet cable. I'm going to pull that. Actually, yeah, I'm going to pull that. And I'm going to use this cable here. This is a fancy pants cable from AllenBradley. They've got the mini DIN 8-pin connector on the end. It's like $50 or something like that. Pretty proud of their device. And I've got a USB to serial converter for my computer. So I got a rather new computer, and it doesn't have a serial port on it. Okay, so we'll do that. Pull that out. All right, and now I'll plug this in to port 0. Come on. There we go. So, oops. There we go. Now I've got a serial connection, and I need to configure VTScada to use that connection instead of the Ethernet, which we've unplugged. Okay, so I'm going to go back to my screen, or my desktop here. So let's go back to the AllenBradley driver. going to look at its properties. So under the type here, we're going to change this. So the PLC address, I'm just going to set that to 1 and change this from a TCP/IP port to a serial modem. Okay. And now I can go to the serial tab here, and I have to create a port tag. So I can do that from within this tag just by clicking on the tag selector and then selecting the new button. So I'm just building a new tag. I'm going to go with the serial port. And this one is, well, I'll just call it COM4 because I believe that's what my, oh, I've already got a COM4. Looks like I built one earlier. So here we go. Here's my COM4. I'll select that. Let me just open that up just so you can see how it's set up. Here's my serial port tag. COM4, that's what my USB to serial port converter is set up as. Here's my baud rate. That has to match the baud rate that's programmed in the PLC using the RSLogix 500 software. I've got no parity, 8-bit data bits, and 1 stop bit. Okay, that's pretty typical. All right, so there's my my serial port tag. I'm going to select that. So now that's selected within my driver tag here. And I don't really need to do anything else here. We've got a straight serial connection, so it's full duplex. And I'll hit OK. There we go. And you can see that we've got data again. Now, just to be certain that I'm using, or that there's no smoke and mirrors here, I'm going to actually disable this tag. Okay, so the AllenBradley driver tag has been completely disabled, and the child tags have also been disabled as well when I did that. So now I'm going to enable it again, and here we go. There's my tags, and you can see that I've got data coming in. Okay, now that's how you set it up for a serial connection. It's pretty simple. All right.
By the way, we just hit the 30-minute mark.
We did?
I spoke for a few minutes off the top, so you've got 5 more minutes.
Oh, okay. I don't think we'll get to the data logger then. I'm sorry.
Oh, in that case, no, actually, never mind. Carry on. Get her done. Okay,
so I do want to show you a couple of the widgets that are appropriate here for troubleshooting purposes. So I'm going to open up the idea, close the tag browser, open up the Idea Studio, and make some room on my my overview page here to get rid of that stuff. And now I'm going to look at the tags. Here's my AllenBradley driver. If I hit the draw button, it gives me the widgets that are appropriate for that type of tag. So I'm going to go with the diagnostics. There's a show COM button, and I'm going to draw it again. Draw the same tag using the show stats button. And there's also the COM indicator. So here we go. Close that out. And now if I go to run mode, whoops. Go. Show COM. This actually shows the data that's being transmitted back and forth between my computer and the PLC. I can look at that in hexadecimal if I wish, so it's real nice for troubleshooting. If I need to hold the data, I can certainly click on the button. So real nice widget. All of our drivers have this feature. There's also show, so it was the show COM button. There's also show stats, and this is great for finding out what the error message is. So if you look at the tag browser here, and if I pull the serial cable out of the PLC, I'm doing that now. Actually, I'll do it here. It's easier. After a little bit, the driver will fail, and then these will go to invalid values. There we go. It failed. Okay, and it says communication failure. Retry limit exceeded. So let me plug my USB serial port back in. This is error number 512, and if we look at the driver tag itself, you can see that it's got a value of 512. Okay, so it doesn't look like it's it's probably because I pulled the serial port out of the PLC, or sorry, out of my computer instead of just disconnecting the cable. So what I'll do here to give it a little bit of a kick is disable the tag and then re-enable it again. That should That should do that. There we go. And now we're back up and running. Okay, so just a real quick troubleshooting technique. All right. Yeah, it's unfortunate that I took so long jabbering. I would have liked to have demonstrated the serial tunnel. If I go back to the PowerPoint here.
Well, how long do you think that'll take?
Well, a few minutes. Okay, you want me to just go ahead and do that?
Yeah, I'll make that executive decision. But well, while we're stopped anyway, for those of you who have to exit, please fill out our survey. There's a little auto-generated exit survey we'd appreciate. And also, we're going to send you in your follow-up email links to this recording and also invitations to join the next 3, which are configuring VTScada thin clients, introduction to version 12, which is coming out soon, and connecting to the IIoT using the new VTScada MQTT driver.
That's a mouthful.
I'm glad I got that all out in one.
All right, so using a serial tunnel. All right, so what I'm going to do now, here, let me stop my thing. So you should look at my camera again. Okay, I'm going to maintain the serial connection here, but I'm going to disconnect it from my computer. I'm going to connect it up into one of these devices. This is a Lantronix UDS 1100. All it is an Ethernet to serial connector. So on one end, it's got Ethernet over here. There we go, Ethernet. And then on the other side, we've got a 25-pin serial connection. Okay, so I'm going to use a serial connection to the PLC, but it's Ethernet from my computer to the to this gateway. All right, so let me get plugged in. The gateway is configured as a with an IP address of 192.168.1.7. Let me plug that back in. I'm going to go back to my AllenBradley driver tag, the properties, and I'm going to leave it at serial here, leave the PLC address at 1, but under TCP, I'm going to go back. How is this going to work? I need to go to TCP IP port. No, serial. Here we go. This is what I need. I'm going to change this to a TCP IP port. So I'm going to create a new tag here. It'll be a TCP IP. So, oops. There we go. And my connection.
I think you need to share your screen.
Oh, I'm sorry. Yep. Thank you very much. Okay, it shows screen. Okay, so here's my driver tag, and I'm creating a TCP IP port tag. Here's the ID, TCP description. Here's the connection. I'm going to go with 502. That's the what the my Lantronix device is configured for. And for the this was 192.168.1.7. Okay, so it's different than the PLC, obviously. It's on its own address. Okay, so hit OK. And there's my port. I'm going to select that from within here. So now my AllenBradley driver tag is going through this Ethernet port, even though this is set up as a serial connection. Okay, so the TCP port is going to encapsulate the serial message within it, and the Lantronix is going to strip that off and send it off to the device. Okay, so stopped. Let me see if I've got any messages. Oh, you know what? I need to finish connecting things up here. Hang on. I don't have the Lantronix connected to the PLC. There we go. Now that's connected. And let me see what the problem is. Should be able to ping it. Okay. Oh, that's network connection as well. There we go. Yeah. Let's see what happens. Try that one more time. There we go. now.
You get points for being able to troubleshoot hardware and software on the fly in a live webinar.
Yeah.
That's cool under pressure.
I'm surprised that this just didn't pick up. Let me give it another kick. You have to say, there we go. And, oh, it looks like I didn't wait long enough. I thought I saw it flash to green there. There we go. And now, well, obviously I got something incorrect. That's how you do it. Unfortunately, it's not behaving itself at the moment. And should have tested this a little bit more before I did the webinar. My apologies. Okay. All right. So that would be the conclusion of my presentation.
Excellent. Well, thank you for that high dive and act. You covered a lot of material there. Well done. By the way, Victor also does almost all of our training in the United States at our training facility there in Orlando. So we actually don't have that many questions to cover. So if anyone else has any questions, please type them in now. Otherwise, we're going to wrap up pretty quickly. I believe the first question, they're all from the same person.
Well, you know, it worked. Sorry, we didn't wait. I didn't do anything. It just worked. Okay, so
gotcha.
Back to the question.
You just have to wait. Well done. So you did get to end on an up note.
Yes, yay!
Turn my camera on here. Woo. Okay, so the one question is, I believe what he's asking is, what operating system are we using? Is that right? Now, chime in, question asker, if I'm asking the wrong question. So what operating system are you using?
My computer is a Windows 10 machine. Things would behave exactly the same if it was Windows 7. So,
okay, great. And in case they're asking a different question, what was the operating system? What was the program you were using off the top of the webinar? Because I think that's when the question was asked.
So to connect to the PLC, there's RS Links Classic Lite. It's the free version. I was using that. That is, here, let me just pop that up. That's this. And it's disconnected now because I'm going through this Ethernet gateway. Right. That's why it's not finding it. So that's RS Links Classic Lite. And the other program to configure your PLC is RSLogix 500. I've got the starter edition here up and running.
Gotcha. Okay, great. And the other question is, this one I'm not sure whether we'll be able to answer. We may have to follow up offline. Oh, we got a few more questions. This program keeps squishing it, so I can't read it. Let's go to webinar. So, does VTScada support IIoT for digital transformation, like Ignition, which supports all the automation stacks from the plant to cloud? It includes MES, ERP, and cloud.
Well, the webinar is about the DF1 protocol and using that to connect to the MicroLogix. That's
so there's a little bit outside of our scope.
But yes, we've got drivers for a lot of different things. With IoT, the big challenge there is standardization on data format. There really isn't a standard for that. Now we do have something that was presented last month, I believe, the JSON driver. Chris, I think Keith did a presentation on that.
Yes, that's right. That was our previous webinar that we did. So if you want to go look at that, and JSON is typically the payload to an MQTT, right? Yeah.
So I'd refer you to that.
And also, I'll say as a bit of a heads up that in version 12, which will be released at some point very soon in the future, we will have a native MQTT driver.
Okay.
And the next question is how to set it up to connect to multiple PLCs. How to set up connecting multiple PLC 90s via 2 radio frequencies.
2 radio frequencies. I guess it would depend on the radio and whether it supports transmit and receive at the same time. Let's see. So let me open up my PowerPoint again, and we'll look at the one slide that I had that shows the connections. There we go, this one here. Okay, so example 2, or actually, if it depends on the radio. If you had multiple remote, yes.
They clarified by saying he meant a 90 MicroLogix 1400.
90 MicroLogix 1400, like a quantity of 90, I imagine. Okay, so you would have to have a radio for each of the devices, obviously, and a master radio. In that case, you would probably want to use a pole driver. That way you can configure the polling sequence. Okay, so each device out in the field would have a PLC and the radio. Depends on the radio, if it's Ethernet or serial. But VTScada, the configuration of VTScada would be trivial. Let me just open up my application again. All right, so you would have let me think. For every remote device, if you were using Ethernet radios and an Ethernet connection between the radio and the PLC, you can do that with cellular. Most cellular.
What about serial?
If it's serial?
Yeah.
If it's serial, then you've got a serial connection to the master radio. You can use the Ethernet tunneling like I just showed you with my electronics. In that case, you're only going to talk to one radio or one remote site at a time. You'll probably want to set up a pole driver. So let me show you a different application here that has that sort of stuff set up.
Cool.
Okay. So I'm going to change my connection to the PLC back to Ethernet, and here's my DNP3 demo that I've got, and here we go. So I've got this set up so that we've got a couple different stations. If I go back here, I've got 2 different stations, both on using DF1, but essentially this would be the same sort of thing. So I've got 2 different stations under the same driver. Normally you would have a station, let's use a pole driver. Drivers, polling driver, let's call this station 1. Okay, and under the I/O tab, I would specify the AllenBradley driver for that particular PLC. Okay, so if you've got 90 PLCs, you're going to have 90 drivers. I would create a new AllenBradley driver tag for that. Child, this will be DF, station 1 AB driver, for example. And make this MicroLogix, go with TCP/IP, or if it's serial, we'll go with serial. And then we'll have to specify the VTScada address, and on the type, we'll have to specify the PLC address. So each PLC out in the field will have to have its own PLC number. And I believe that is octal. So be aware of that. There we go. So there's my driver. I'll select that as my driver here. And then I would create, so here's my station 1 tag. What happened here? I lost my my driver tag. What happened? Excuse me for a minute. Well, let me just build another one. Station 1, new child. This will be AllenBradley, AB, ERV1. type, MicroLogix PLC1, be serial, address there, we're all set. Probably want to go with the radio modem. The difference between the full duplex or the half duplex and radio modem is that the radio modem removes all of the AX, the NAX, and E and Q commands. So it simplifies the communication between the VTScada and the PLC. So instead of having 5 messages being transmitted for each transaction, there's only 2, send and a reply. Okay, so the radio modem is a lot more efficient that way. The CRC is the data integrity check. Okay. All right, so there we go. And then I'd have to set up a port, which would be the port that would point to the serial radio, the master radio. So I would do this, and then create all of my I/O tags underneath this. Analog status here, status 1, and so on. I build all of my child tags under that, and then I duplicate this over and over again. If I had 90 different remote sites, I'd have 90 different pole drivers, 90 different AllenBradley driver tags, and then all of the associated I/O tags underneath that. Okay, I hope that answered your question. That was a pretty quick run through of that. If you have any questions on it, you can always give me a call.
That's true. Victor's number is listed on our website under the Orlando office. Let's see here. Now, what did Victor change in the driver tag when he went from the serial connection to the Ethernet device? I missed that piece.
Oh, sure. Okay, so right now, if I look at this particular driver, this is set up for Ethernet IP. There's the IP address, TCP IP. If I wanted to change that to serial, I would change this to the PLC address. Okay, so on the serial side, it would be PLC number 1. I would change this to a serial modem connection, and then on the serial tab, I would put in my port here, so COM4, my serial port. Okay, and then hit OK.
Great. Excellent. Is there a limit to the number of ML1100, ML1400, and SLC5/05 PLCs that VTScada can communicate with in a single application?
It depends on no, there isn't. Unlimited. It's really dependent on your network and your computer, if you've got in the extreme case, let's say you've got 1 million PLCs. If they're all on a high-speed network, VTScada can handle it internally, but your network might not be able to handle all of that network traffic over, an Ethernet network. If you had serial connections, then obviously you're limited there on the bandwidth of your serial connection.
And would the tag band affect that at all? Like your actual licensed I/O tag band, like how many I/O you're licensed for, would that matter, or are we not talking about that kind of number?
No. The license count on when you purchase a license for VTScada, it limits the number of tags that you can use to communicate with your devices. Those are only I/O tags. It does not, the AllenBradley driver tag does not go against that tag count. Only analog status, analog control, digital status, digital control, so on. The I/O tags that actually write values and read values. The infrastructure, like the driver tag and the pole driver tag and the port tags, those don't go against your tag count at all.
Also, there was an add-on to that last answer. Sorry, I forgot to add that the communication would be via Ethernet. Did that change your previous answer at all?
Is that the question for the number?
I'm sorry. The ML1400 SLC 5.
The limit on the limit on the number of PLCs that can be connected?
Yes.
No. Yeah, it's not software limited. It's limited on the hardware side. Like I said, if you had 1 million PLCs connected over a gigabit network, yeah, you might be able to talk to all of them, but that would be a pretty busy network, especially if you had a lot of I/O tags. And if you're pulling them every second, if you pull them every 1/10 of a second, then you're going to overload your network again. Again, the software is not limited. It's the hardware that's the problem in that sort of scenario.
Great. Coming on the last question, we've hung on to almost all of our audience. That's great. The last question is, does VTScada recognize duplicate data in DF1?
Duplicate packets are recognized. Yes, that's dealt with internally to the driver.
Right. So you don't have to do anything.
No. Great. I'm not sure if it'll give you a notification of that or not. I've shown you the show comms and show stats widgets. Those are very valuable in troubleshooting any sort of error, especially the show stats. If you look at the tag database in the tag browser, and your driver tag has a value other than 0, 0 means no error. If it has a value something other than 0, then you can look. If you open up that widget, it'll show you the error message, which leads me to believe that I should have mentioned when I open up this driver the help file. So if I go to properties here and I go to type, I'm going to hit my F1 key on my keyboard, and that'll bring up the help file. Unfortunately, it's on a different monitor, so I'll bring it over here. There we go. And here is the help file for my AllenBradley driver tag. And it's got all sorts of wonderful information in it. Another entry in the help files is located here. If you look in the menu on the right, is a driver I/O addressing. That was one of the slides that I popped up in my presentation. And the other thing that I wanted to point out is the error codes. They're also listed here. So you don't have to use that widget to get the error codes. They're also in the help files. Okay, there's a whole slew.
So with the combination of the help and the tutorials that are available in the help, and if people had, say, the 50 IO free license of VTScada, you can download that from our website without filling out a form or anything. Just says try VTScada Lite. Will people be able to try this for themselves if they use the help and this video and the VTScada Lite license?
Yep, no problem. I guess if you run into trouble, you can call tech support, or you could check out our forum.
Yeah, probably best. We actually do most of the support for because it's a free license, and we do actually have our actual support people answering questions on that forum. But it's an easier way, since the license is free. It's an easier way to support that without sort of choking the bandwidth for our paying support customers. Sure. So I encourage everybody to. We'll actually include that link in the email that goes out to download VTScada Lite, and you'll be able to walk your way through the tutorial. We also have videos on our website that show you how to get started using VTScada, how to install, create an application, do similar kinds of connections to similar kinds of devices. In fact, we've got a handful of these webinar videos that we did before this that you can draw from. So there's lots of different ways for you to get up and running very quickly if you want to get started using VTScada. So on that note, anything else, Victor? I
think that covered quite a bit. So,
all right. Great job. You did a lot of great work today. So like I said, we'll be sending out invitations. We'll be sending out follow-up emails with the recorded webinar. And just to remind you, the next 3 webinars are next month. We'll be configuring VTScada thin client connections. So that's using your tablets and your smartphones to connect to your process. In July, August will be introduction to VTScada 12. So there's a lot of really great features that I can't tell you about yet, but are awfully exciting. And then in September, we'll be talking about IIoT, so connecting to the IIoT using our up-and-coming MQTT driver. And on that note, thanks, Victor. Thanks, everybody, for tuning in, and we'll see you next time.
Great.